In this video for Math 98, we'll be covering problems from section 14.3 and 14.5. These are examples from homework number 9, and they're like problems 11 through 19 on the homework. This is the final section in Math 98. We're going to talk about the topic of sequence, and let's consider this situation. Suppose you are given a job, and your pay for this job is as follows. The first day, your pay is only 1 cent. But from that day forward, your pay is double the previous day. So the second day, you would get 2 cents. And the third day, you would get double 2 cents, or 4 cents. This doesn't sound like a very good deal, does it? How much money will you make on your 30th day of work? And how much money will you have made altogether? If we take the amount of money that we make each day and we list them in a row like this, 1 cent, comma, 2 cents, comma, 4 cents, comma, the next one, of course, would be 8 cents, and then 16 cents. This is an example of what we call a sequence. A sequence is just a collection of numbers like this. A more formal way to say that is a sequence is a function whose domain is a subset of the whole numbers. That's confusing. Let's see what that means. You might remember function notation f of x, where this is the input, or domain, and the answer is the output. So I could write this sequence right here by saying the first item in the sequence, f of 1, is 0.01. The second item is 0.02. The third item is 0.04, and the fourth is 0.08, and so on. This gets cumbersome, so we have a special notation in mathematics. When we're referring to a sequence, we use a variable, such as a, with a subscript, such as 1, to mean the first item of the sequence. So this would be a1. This one would be a2. This one would be a3. This one would be a4. So a5 would be the next one, and we know the pattern here. It's going to be 16 cents. So that's a little bit about the notation and idea of a sequence. Let's take a look at a few examples. Here's a sequence, 1, 5, 9, 13, 17, 21. This would be a1. This would be a2. This would be a3. This would be a4. This would be a5. Okay, put commas in between. And this would be a6. Here, this sequence is a little different. 5, 1, 1/5, 1/25. You don't have to use a, but in this book we use a all the time. A is 5. A2 is 1. A3 is 1/5. A4 is 1/25. These 3 dots means continues on that pattern. You might notice a pattern to these two sequences. Here's one where it's got a little different pattern. I would have a1 equal 1, a2 equal -1, a3 equal 1, a4 equal -1, a5 equal 1, a6 equal -1, and so on. One thing you can notice about these sequences is in this case, I add 4, I get 5. I add 4, I get 9. I add 4, I get 13. In this case, I divide by 5, or multiply by 1/5 to get 1. I multiply 1 by 1/5 to get 1/5. 1/5 by 1/5 to get 1/25, and so on. Sequences that have patterns like this are the ones that we are interested in, and we're interested in 2 different types. The first type being what we call an arithmetic sequence. An arithmetic sequence is one where you add the same value to get the next term. Let's take a look. Here's an example of an arithmetic sequence. 2 plus what is 5? Well, clearly I add 3, and 5 plus 3 is 8, and 8 plus 3 is 11, and 11 plus 3 is 14. This number 3, if it happens to work this way, in an arithmetic sequence is called the common difference. We use the symbol for D for that, and in this case, D is 3. Now, one of the questions that we're interested in with the sequence is, can we find a term further on down the road? There's 2 ways to do this. There are explicit formulas and recursive formulas. An explicit formula, let's think about this. The first term, a1, is 2. The second term is 2 plus 3. The third term is 2 plus 3 plus 3, or another way to write that is 3 times 2. The fourth term is 2 plus 3 times plus 3 plus 3 plus 3, or another way to say that is 3 times 3. If I call this a1, and this a2, and this a3, and this a4, you'll notice if I write 3 times 1 here, that the only thing changing here is this value right here. Every single time you have 2 plus 3 times a number. And I can even write this as 2 plus 3 times 0. If this is the case, it's not too hard of a stretch to say that the nth term is the first term plus 3, in this case 3 is so my first term, is 2. 2 plus 3 times this value here, that's subscript minus 1. So I can have 2 plus 3 minus 1. I can clean that up. That's 2 plus 3n minus 3. Another way to write that is 3n minus 1. So that's called an explicit formula. It might be easier to think about what is called a recursive formula. One way to think about the sequence is the next term, a to the n, is 3 plus the previous term, right? This is called recursive because it's not defined in terms of a term number. It's defined in terms of the previous term. It's defined in terms of itself. Now, you also need a starting point, and the first part of this is a1 equals 2. Now, we can generalize this process for arithmetic sequences in this way. An explicit rule for the arithmetic sequence is the nth term equals the first term plus n minus 1 times that common difference. A recursive rule for this arithmetic sequence is the nth term equals the n minus 1th term plus d, where a1 is given. Let's look at an example from the previous page. This is arithmetic because you're adding 4 each time. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17, 17 plus 4 is 21. So if I want an explicit formula, I can look at it this way. Now, the first term is 1, and I'm going to put n minus 1 in there, and the common difference in this case is 4. So a to the n equals 1 plus 4 times n minus 1. That's perfectly fine. If you want to clean this up, you'll get 4n minus 3 if you do the arithmetic. For a recursive example, you could say an equals an minus 1 plus that common difference, which in this case is 4, and you have to list the first term as being 1. Here's another example. You might want to try this on your own and start the video when you're finished. Notice here the common difference is 5. I'm adding 5 each time to get these things. So for an explicit formula, I have the first term plus n minus 1 times 5. And again, you can clean that up and get 5n minus 9. Okay? For a recursive formula, I could say a to the n equals the first term, which equals the previous term, a to the n minus 1, plus 5, and the first term is equal to negative 4. Either way gives you the sequence. Not all sequences are arithmetic. Sequences where you multiply the previous term by a common value are called geometric sequences. Here's an example. 25, 5, 1, 1/5, 125. In this case, I divide 25 by 5, or I say 25 times 1/5 equals 5 to get the second term. And 5 times 1/5 equals the next term, and so on. This factor that I'm multiplying by is called a common ratio. In this case, that's 1/5. Now, an explicit formula, if you think about this, we started with 25, And then we did 25 times 1/5 to get 5. And then to get 1, you do 25 times 1/5 times 1/5. Another way to say that is 1/5 squared. The next term is 25 times 1/5 to get 5 times 1/5 to get 1 times 1/5 to get the next one, which is the third. So this is my first term, my second term, my third term, my fourth term. The only thing changing here is this exponent, and you'll notice it's one less than this number n. So a to the n equals the first term times the common ratio to the n minus 1 power. A recursive formula is pretty simple. The nth term is the common ratio times the previous term, and the initial term you start with has to be given. Let's go back to our original problem. Here is my set of money for this job. What is my formula for the nth term? My formula for the nth term is my first term, 1 cent, times my common ratio. You might remember my common ratio, every day I'm doubling my salary, so I'm multiplying by 2. So this is 2 to the n minus 1. Now, a question I asked at the beginning of this class was, what is this after 30 days? So if I let n be 30, I have this crazy number. I'm going to get my calculator. Certainly no one could do that in their head. And I'm going to try that. So let me quit out of this and clear all this stuff. I'm going to get 0.01 parentheses 2 n parentheses raised to the 29th power. So here's how much money. I'm just going to write these digits down. 5368709.112. My salary on the 30th day will be $5,368,709.12. Now this looks like a pretty good deal. In general, for an explicit formula of a geometric sequence, the nth term equals the first term times the common ratio to the n minus 1. And for a recursive formula, the nth term equals the previous term, a to the n minus 1 times r, and the first term has to be given. So let's do some problems from WebAssign. I'd like to identify each sequence as arithmetic or geometric, and then write a recursive formula for each. So here we have 20, 18, 16, 14, 12. It's pretty clear this is arithmetic with a common difference of -2. We're subtracting 2 each time. So a recursive formula will be an equals the previous term plus the common difference, which is -2. And the first term, of course, is 20. Let's take a look at this one. 10, 18, 26, 34, 48. Well, if you do 18 minus 10, you get 8. 26 minus 18, you get 8. Does 8 add to 26 give you 34? Sure. 34 to 42 gives you 8. So the nth term equals the previous term plus 8. And the first term, of course, equals 10. Here's one. Let's see if this is, so these both were arithmetic. Let's see if this is arithmetic or geometric, and what you think the answer might be in this case. Well, arithmetic doesn't work. I add 12 here, but this is much more than 12. So that's a hint that I might want to use geometric. I multiply by 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So geometric, the recursive formula is the nth term equals the n minus 1 term times 4, and the first term equals 4. So these two with arithmetic, this was geometric. All right, let's look at another example from WebAssign as I turn the page here. Write an explicit and recursive form for each sequence. So I need to identify, are these sequences arithmetic or geometric, and then use my formulas. If you look at this, clearly we're multiplying by 3 each time. So an explicit formula, this is geometric. So an explicit formula is given by this. So my first term is 3. My common ratio is 3 to the n minus 1. And a recursive formula is given by the common ratio times n minus 1, where a1 equals 3. Okay? Here, what about this one? Well, again, this is geometric, the common ratio of 1/2. So, explicit formula is a1 r to the n minus 1. My first term is 64. This is 1/2 to the n minus 1. This one is also geometric. And you'll notice the common ratio is 3. So, what's the explicit formula? A to the n equals a1 times r to the n minus 1. So 6 times 3 to the n minus 1. And recursive formula is r times a to the n minus 1. So that means it's 3. Excuse me, that's a funny looking 3 times a to the n minus 1. And of course, don't forget to put the first term in there too. So that's a little bit of stuff from WebAssign. Let's look at a few applications. Jeff bought a block of tickets to a play. The tickets are numbered 53 to 99. If we consider this block of tickets a sequence, I want to write an for the sequence. And how many tickets did he receive? Well, my sequence is 53, 54, 55, if he bought this whole thing up to 99. So if this is A1, this is A2, this is A3, so on, we want to know how many do we have. So let's write a little formula for this. I notice that this is arithmetic. And what is my common difference? My common difference is 1. I add 1 for 53 to get 54. I add 1, 54 to get 55. So I'm going to use this formula. Now I know that my nth term is my first term plus my common difference, which is 1 times n minus 1. That is so simple, I think I'll just write that a different way. A to the n equals 52 plus n. So that is my a to the n. How many tickets did he receive? Well, that would be how many terms are in the sequence. So I want to know if I'm at 99, how many terms do I have? So 99 minus 52 is 47. Now I want you to know that that is not 99 minus 53. If you're doing that, you're looking at the numbers in between these, and you're not including the endpoints. So that's why that's a little bit different than the answer would be if you just did subtraction. So there are actually 47 tickets in there. Here's another example. Sharon changes her car's oil every 3,000 miles. She bought the car at 22,000 miles and immediately changed the oil. At 109,000 miles, she changed the oil again. How many oil changes has she made altogether? So, you know, she bought the car at 22,000 miles, and being very studious, she changed it 3,000 miles later, 3,000 miles after that, all the way up to 109,000 miles. So if this is A1, this is A2, this is A3, I want to know how many of these there are. Notice again, this is arithmetic. And your common difference this time is 3,000. So see if you can write an nth term formula for me. It's the first term plus the common difference times n minus 1. Now, I'll clean that up a little. That's going to be 22,000, that's going to be 3,000 n. 22,000 minus 3,000 is plus 19,000. So that's a to the n. Now I want to know when is that 109, 109,000. So how many oil changes has she made? So to solve this problem, I'll let you solve that. That's 109,000 minus 19,000 gives me 90,000. So she's driven 90,000 miles in that time period. Divided by 3,000. And that's going to say that she has made 30 oil changes. Notice this counts the oil change she made right away when she bought the car.